Hello dear students, welcome back to the NEET Crash Course Physics 2026. So students, in the earlier two lectures, we have completed the chapter Algebra and Trigonometry of the portion Basic Maths. In this lecture, we will cover coordinate geometry and graphs. So without losing any time, let's start. So first we have to consider two-dimensional system, and whatever formula we use in two-dimensional system, the same formula will be used in three-dimensional system with the addition of one more term, that is for the z coordinates, isn't it? So this is known as Cartesian plane. This is having x-axis, so this is plus x, this is negative x-axis. This can be written as x prime or negative x. This is y-axis and this is y prime, or you can say minus y-axis. This point is center, that is origin, intersection of x-axis and y-axis. And if there is x-axis, then z-axis, then z-axis will also pass through this origin. So how z-axis is defined? In two-dimensional system, we use only two axes, because if the two-dimensional system, we use to define the location of any particle which is in the plane. For example, if any insect is moving in this plane of the board, so its location is defined only in this plane. Suppose if it is the insect is here, the insect is here, so we can define its position by using these two coordinates and these two axes. We don't require the third axis. But suppose we have to define the position of a butterfly, so it is a butterfly will fly along this room as well. So its position, to define its position, we require a third axis as well, which is z axis. So z-axis will also pass through the origin, but it is perpendicular to the plane of the board, and positive z-axis will come towards you. And if I talk about negative z-axis, then it will perpendicular to the plane of the board, but into the board. So this is the difference between the positive z-axis and negative z-axis. So first we have, let us learn how can you locate the position of any particle or any point which is in plane. So suppose the coordinates of any point P is 2, comma 3. So this 2 corresponds to x-axis and 3 corresponds to y-axis. And if there is one more axis, that is z-axis, then we will have one more number after point 3. So we will look at that as well. So first we have to locate point P. So how can we locate point P? So we move towards x-axis by plus 2. So this is plus 1 and this point is plus 2. Isn't it? So we move towards x-axis plus 2 distance, and after that we move towards y-axis towards plus 3. So this is positive y-axis upper side, so plus 1 plus 2 and plus 3. So this is plus 1 plus 2 and plus 3. So location of this point is as follows. First we move towards plus 2, then plus 1 plus 2 plus 3 along y-axis. So this is representing point P having coordinates 2, comma 3, isn't it? So this distance is 2, this distance is 2, and this distance is y. It means that if I mark this distance, so this distance is 2, and if I mark this distance is 3. Now let us suppose, let's represent another point Q having coordinates minus 3, comma minus 4. So minus 3, so this minus 3 corresponds to negative x-axis. So this is minus 1, this is minus 2, and this is minus 3. Negative x-axis, here it is minus 1, minus 2, minus 3, minus 4. So this is negative y-axis. So we have to locate point Q, minus 3, minus 4. So first we move towards minus 3, so minus 1, minus 2, minus 3, then we move towards minus 4. So minus 1, minus 2, minus 3, minus 4. So this point is representing point Q having coordinates minus 3 and minus 4. So this distance is minus 3, and this distance from here, this is minus 4. Are you getting that? So in this way we use this Cartesian plane to represent any point, to represent the position of any point or particle. Now suppose there is third point having coordinate 1, comma 2, comma 3. Now I am taking the example of three-dimensional system. Suppose there is an insect flying, and at some moment its position is 1 comma 2 comma 3. So what we do, first we move 1 towards x-axis, then 2 towards y-axis, and then plus 3 towards positive z-axis, because here it is plus 3. So we move towards perpendicular to the plot and towards the camera, I mean towards you. So this is plus 1 plus 2, and now towards positive z-axis, that is plus 1 plus 2 plus 3. So this is the position of this particle. Are you getting? Plus 1 plus 2 plus 3. So this is how we locate the particle. So you don't need to visualize it. We have to just use the formula. I am just giving you the example so that you have to must have some general idea, isn't it? Now let's have a look how can we find the distance between the two given points. So let us suppose I am drawing two axes. So first we understand the formula by using two-dimensional system, and the same formula will apply in the for three-dimensional as well. So this is x, this is negative x-axis, also x prime, this is y-axis, and this is y prime. Now suppose I am drawing we take two coordinates. So let us suppose I am taking two coordinates as point P and point Q. Let us suppose this is point P, this is point P, and this is point Q. Having coordinates, this is point P, this is point Q. P is having coordinates, let us suppose x1, comma, y1. Q is having coordinates x2, comma, y2. Isn't it? We have to find the distance between P and Q. So how can you find? So first, we will join point P and Q. We will join point P and Q. So we join point P and Q. Now marking the distance of point P from the origin. So representing it by dotted line. Now, dear students, let us mark the distances. So observe carefully. The coordinates of point P is x1. So to locate point P, we must move x1 distance towards x1 and y1 distance towards y1. So this distance is actually y1, and this distance is x1. Similarly, if we wish to locate point Q, then we must move x2 distance towards x1. So this distance is x2, and this vertical distance of point Q from the x-axis is y2. Because to locate point Q, we must move x2 distance towards x-axis, and from x-axis we must move y2 distance towards y-axis. So this distance is y2. Now let us suppose this point is R. Now observe carefully. This whole distance is x2. That is the distance of R from this y-axis is x2. Distance of point P from this y-axis is x1. So this is x2, this is x1. So this distance is x2 minus x1. This distance is x2 minus x1. Similarly, this whole distance is y2 and this is y1. So distance q is y2 minus y1. Distance qr is y2 minus y1. So observe the graph carefully. You will get that the distance pr is given by x2 minus x1. Distance qr is given by y2 minus y1. And the distance PQ, if you observe carefully in triangle PQR, this is triangle PQR, this angle is 90 degree. So this PQR is forming a right angled triangle. So we can use Pythagoras theorem here. So this PQ will become hypotenuse and this PQ square is given by PR square plus QR square. So this PQ square is given by PR square plus QR square. So what is PR? PR is x2 minus x1 square plus y2 minus y1 square. So this is PQ square. So taking square root both side. So here it is PQ. This is root over x2 minus x1 square plus y2 minus y1 square. So this is the distance formula, dear students. If any point is having coordinate x2, x1 and y2, y1. So what is the distance formula? So let us summarize distance formula. Distance formula between any two points whose coordinates is given such that A is having coordinate x1, y1, B is having coordinates x2, y2, then the distance AB is given by x2 minus x1 square plus y2 minus y1 square whole root under this root. Isn't it? So this is the formula, distance formula. From its derivation, I have shown you the derivation. Now suppose there is a third coordinate as well. Now we have to find, suppose the coordinate point P is having coordinates x1, y1 comma and z1, and point Q is having coordinates x2 comma y2 and z2. Then distance between PQ is given by root over x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Isn't it? The formula is same. Just one more term comes here, that is z2 minus z1 square, because they are having z coordinates as well. Isn't it? So it is very simple. Na? It is very simple. In kinematics or in vector, this formula is very useful, where you will have to find the distance between the 2 points. Suppose the coordinates of 2 points are, the coordinates of A is -1 comma -2 and coordinates of B is 2 comma 4. Now in question you have to find the distance between point A and B. Suppose the initial position of any particle is A and the final position is B, and the question is asking you to find the distance covered by the particle. So you have to find the distance between A and B ultimately. Isn't it? If the initial position of particle is given as -1, -2, final position is given as 2, 4, and you are asked to find the distance covered by the particle. So actually it is asking the distance between point A, B. So direct apply the formula. The distance AB is root over, now the first term is x2 minus x1. So observe carefully, this is x2 is 2 minus x1. x1 is -1 whole square. So this is x2 minus x1 square plus y2 minus y1 square. y2 is 4 minus y2 minus y1. y2 is 4, y1 is -2. So be careful, square. So this will be minus plus. So 2 plus 1 3 square 9 plus this will be minus plus 4 plus 2 6 square 36. So this is 36 plus 9 is 45. So root 45 can be written as 5 into 9. This can be written as 5 into 9. So this will be root 5 into root 9. And root 9 is 3. So this is 3 root 5 meter. So you have find the distance covered by the particle, that is 3 root 5 meter. So in this way we can use the formula. So coming to the next section, that is graph. So dear students, in physics, basically there are three types of graphs. First is straight line, second is parabola, and third one is hyperbola. Out of these three graphs, the most relevant one is straight line, then parabola, and then hyperbola. And these graphs play a very important role in the mechanics portion of the physics, in the modern physics, in thermodynamics, in oscillation and waves, in almost all the sections of physics. These graphs play a very crucial role. So if you are a serious NEET aspirant, then you must take very seriously this section, that is graph. Because there are many such problems which require the knowledge of graph, and if you don't know it, then it will be very it will be very I mean, you will find very difficulty in such questions which has the application of graphs. So first of all, let us understand the most relevant one, that is straight line equation or straight line graph. So what happen? Any equation of the form ax plus by plus c is equal to 0 can be represented using straight line. है ना? So how can you I mean, by observing this equation, how can you say that this will be represented by straight line equation? That observe the power. Here the power of x and y is 1. So whenever the power is 1, that is the degree of an equation is 1, then graph will be straight line. Suppose if I put power 2 in x, then this will become a quadratic equation and that will be represented by parabola. Suppose if I put minus 1, power minus 1 in x, then that will be represented by hyperbola. So one by one, let us start from this straight line equation. So the very general form of straight line equation is, I am writing here, and that is y is equal to mx plus c. Now I will show you from where this formula comes, where m is given by slope is equal to tan theta is equal to rise by run. I will explain it, isn't it? What is c? C is known as y-intercept. Y-intercept. That is the point where the y-axis cuts the graph, isn't it? So c is known as y-intercept. Now let us understand this by using the graph. That is, suppose I am plotting a xy axis. So as you all know that this is x-axis. So this is x, this is x prime, this is y, and this is y prime. And if I plot a graph like this one, isn't it? So this is a straight line curve. This is a straight line curve, and this straight line cuts this y-axis at this point. So this point is known as C. That is, this distance is C. This is known as y-intercept. The point where the straight line cuts the y-axis is known as y-intercept, isn't it? Now, if this graph passes through the origin, then the value of C will be 0. If this graph passes through the or cuts the y-axis along the negative y-axis, suppose here it cuts somewhere here, then the value of C will be negative. But in this case, the value of C is positive. So this distance is the value of C, isn't it? Now what happens? Suppose I am choosing some point P having coordinate x, y. Are you getting? Having coordinate x and y. Now I extend this line as like this one. Let us suppose this is point P, this is C, and this is point Q, isn't it? Now what happens if I take tan theta? Suppose this angle is theta. So tell me, this is C, this distance is C, this distance is y, this distance is y, and this distance is x. As we have seen earlier, how can we locate point P? To locate point P, we must move the distance x towards x-axis and the distance y towards y-axis. So it must be, this distance must be x and this whole distance is P, because from x-axis we move y distance to locate point P. That's why this distance is y and this is C. And this distance is y minus C. This distance is y minus C. So if I wish to find slope of the line, slope of which line? Slope of this line, this green line. The slope is given by rise by run. Rise by run, isn't it? What is rise? The vertical distance. What is run? The horizontal distance, isn't it? So when you move from point C to point P, how much vertical distance you have covered? That is y minus c. And how much horizontal distance you have covered? That is x, isn't it? So the what is slope when you move from point C to point P? So slope is defined as rise by run. By moving from point C to point P, how much distance you cover along y-axis is y minus c, and how divided by run, that is how much distance you covered along x-axis, that is x. And this slope is represented by m, and this is also tan theta, isn't it? The slope is also tan theta. Why? Because when you move from C to P, the vertical distance you covered is y minus c, and horizontal distance you covered is x. And what is y minus c by x? Observe the triangle C, P and Q. This y minus c is perpendicular, and this x is base. So perpendicular by base is tan theta. So this is slope. So y minus c by x is equal to m. So y minus c is equal to mx, and finally you will get y is equal to mx plus c. So this is how we get the equation of a straight line, isn't it? Y is equal to mx plus c, where m is the slope. What is slope? That is tan theta. So it is nothing, slope is nothing but vertical distance per unit horizontal distance. It is actually defined as like this, isn't it? Now let us have some example so that you can understand it more clearly. So example number A, suppose you have to represent y is equal to x root 3 plus 1. Observe the equation and the graph carefully, because the direct question, there are many questions which are directly linked with such examples. So I am explaining the very selected examples. So here, my dear students, if you observe carefully and compare it by standard equation of a straight line, so this is xx. So in the place of root 3, I mean the place of slope there is root 3, and the place of c, that is y-intercept, there is 1. So how can you plot the graph? So first plot x and y. So this is x axis and this is y axis. So the graph must cut the y axis as at plus 1. So this is point 1. So graph must pass through this 1. Why? Because here the c is y-intercept is 1. It means that the straight line must pass through this point 1, because c is equal to 1. This straight line which passes through 1 may have slope like this, may have slope like this, may have slope like this. There are infinite number of lines which can pass through this point 1. But we have to select only that line whose slope is root 3. Now this is very important. We have to select only that line whose slope is root 3. So this is very important. So here the slope of the line which is passing through the point 1, so this slope is given by tan theta, and that is equal to root 3. And tan theta is equal to root 3. It means that theta is equal to 60 degree, because tan 60 is equal to root 3. So how can we find this value? You can learn it from the lecture 2. है ना? So the graph would be like, straight line would be like forming a 60 degree. So how can you form 60 degree? This is horizontal line, and from here you will draw a line. From here you will draw a line which is having 60 degree with this line. So in this way, so this straight line represents the equation y is equal to x root 3 plus 1, where 1 is the y-intercept and root 3 is giving the slope. So this is the straight line. You are getting it, isn't it? Now let's have some more examples. Suppose I write y is equal to x minus 3. I have to represent this one. So how can you represent? The very first is compare it with the standard equation mx plus c. So this can be written as, observe carefully, this can be written as x can be written as 1x plus minus 3, isn't it? So in terms of so here m is plus 1 and c is minus 3. So first of all, what is m? That is slope, and slope is tan theta. Tan theta is 1, implies that theta is equal to 45 degree. It means that the slope of the straight line is 45 degree. And the second important information we are getting from here is c is minus 3. It means that that straight line must pass through the minus 3. So this is negative y-axis, minus 1, minus 2, minus 3. So this point is minus 3. So the graph must pass through this line, and the angle made by the graph is 45 degree. So this is the straight line. Are you getting how can we plot a graph or draw information from the given equation? This is very important. Now let's have some examples of suppose if I write the equation y is equal to x, y is equal to 0, or you can write y is equal to suppose y is equal to 0. You have to represent y is equal to 0. So how can you represent y is equal to 0? So dear students, y is equal to 0 is represented by x-axis, isn't it? Because this is x-axis, this is x-axis. You move along x-axis, any point will have its y coordinate as 0. For example, here it is 1 comma 0, here it is 3 comma 0. If you put minus 1, minus 2, here it is minus 2 comma 0. So in this x-axis, each point or every point has the y coordinate as 0. So what we say, x-axis represents the equation y is equal to 0. Similarly, if I represent the equation that this x is equal to 0, so this x is equal to 0 being represented by y-axis, because at every point of y-axis the coordinate of x is 0, isn't it? So this is very important. Suppose you have to represent x is equal to a. How can you plot x is equal to a? Let us suppose this is 1, 2, 3, 1, 2, 3. So what information does it carry? That no matter what the value of y is, the value of x must be a. It means that suppose I write here x, a. This is a. So the graph would be like, it must pass through this a. So this line which is parallel to y-axis is representing x is equal to a, because at every point of this line the value of x is a. This is parallel to y. So what is being represented by x is equal to a? So it is definitely, it is a straight line because the degree power of x is 1, but it is parallel to y-axis, and cuts the x-axis at a. Isn't it? Similarly, if you plot y is equal to b, if you wish to plot y is equal to b, then how can you plot y is equal to b? So let us suppose this is b. So what does it mean? It is also a straight line. At every point of this straight line, the value of y is b, the value of x increases if you move towards right. If you move towards left, the value of x decreases. But at every point, the value of y is b. So this is nothing but y is equal to b is parallel to x-axis and cuts the y-axis at b, isn't it? This line is a straight line, it is parallel to x-axis. So this is the straight line representing the equation y is equal to b. So any value, if you represent y is equal to c, d, suppose you have to represent y is equal to 3. So how can you represent? So this line, this is having plus 3. So at every point on this line, this is having its y coordinate as 3, and the value of x increases if you move right side, the value of x decreases if you move left side, but the value of y remains 3. So this line parallel to this x-axis and passes through plus 3 on the y-axis is represent this equation y is equal to 3. So y is equal to some constant. The graph of y is equal to some constant is parallel to x-axis, and the graph of x is equal to some constant is parallel to y-axis. Now let us understand the negative slope, positive slope, and zero slope. So plot a curve showing zero slope. So what is zero slope is being represented by, so any curve which is parallel to x-axis, parallel to x-axis, its slope is 0. Why? Because slope is tan theta. Tan theta is equal to 0. It means that theta is equal to 0. And how we take theta here? We take theta from the line parallel to x-axis. For example, in the earlier examples, we take this theta from this line, and this line is parallel to x-axis, isn't it? So what happens whenever we talk about slope, so we take tan theta, but that theta is being measured by the line which is parallel to x-axis. So here we take 45 degree from this blue line, and this blue line is parallel to x-axis. Now if I rotate this line, so the slope angle will get reduced, and if this line coincides with the line which is parallel to x-axis, then the theta becomes 0 and we have 0 slope. And I rotate it further, then the slope will be negative, dear students. So here positive, this is line parallel to x-axis is slope 0. Positive slope positive means the line is like this one, isn't it? So whenever you take theta, so for theta greater than 0 degree but less than 90 degree, isn't it? The slope will be positive, because for this value tan theta is equal to positive. So these are the positive slopes. There can be many lines. This line, this line, this line, all are having positive slope because it is giving the effect of rise. When you move towards on this line, you will have some rise, isn't it? I can draw many lines here. Suppose in this line. Now when you move from point A to point B, its slope is positive because when you move from point A to point B, there is the vertical shift. There is a vertical shift towards upside, isn't it? If I can draw many lines. For example, from if you move from P to Q, there is a vertical shift upward direction. So this is positive slope. Similarly, if I draw another line, suppose here it is P and here it is Q. So when you move from P to Q, neither you vertically shift upward nor you vertically shift downward. Your y position is same. So this is nothing but slope 0. It means that theta is 0. Now the third is, if I plot a straight line like this one, here it is P, here it is Q. Now if we move from point P to point Q, there will be negative slope. You vertically shift downward, and the theta, so from where you can take theta, we draw a line parallel to x-axis, and this angle theta is being measured in clockwise sense. That's why this angle theta will be taken as negative, and its tan theta will have negative value. That's why this corresponds to negative slope. This corresponds to negative slope. So we have learned this tan theta, when tan theta will be negative, positive in the lecture 2. You can have a look at it. So these are different cases of slopes. Now the one more example. Suppose if I plot a straight line parallel to y-axis. This is parallel to y-axis. This is a straight line A B. This is parallel to y-axis. Now, if I measure its angle from a line parallel to x-axis, so this angle is 90 degrees. So its slope is tan theta. So here it is tan 90 and this is infinity. So infinite slope means the line is parallel to y-axis. Zero slope means the line is parallel to x-axis, isn't it? So that's all. So one very important thing, dear students, finally I am summarizing it. So whenever you need to find slope now, you have to take angle. Whenever you are asked to find slope of any line, suppose this is a line. So what you do, the very first step, if you need to find slope, then the very first step is construct a line parallel to x-axis, and then this theta, and if you take its tan theta, so this will give you slope. Are you getting? So what is slope? Slope is equal to tan theta represented by m, and theta is taken in this way. First, suppose you have to find slope at point P, na? So you have to take theta at point P. So how can you take theta at point P? First, draw any line parallel to x-axis which is passing through this point P, and then take inclination of this line from this reference line theta. Now here you are taking theta anti-clockwise, though its slope is positive, isn't it? Now suppose the line comes or coincide with this line, then theta will be, suppose the line comes like this, coinciding with this line, then theta will be 0, that is 0 slope. And suppose the line goes like this, then theta will be negative. So this red line will have negative slope. So this is the logic. Now the second graph is parabola, isn't it? So any equation like this one, ax square plus bx plus c, that is quadratic equation, that is the highest power of x is 2, is being represented by parabola. Now there are many cases, but here it is a condition that a is not equal to 0. It means that x square term must be there, only then the graph will be equation will be represented by parabola. So how can we plot the parabola? So there are examples. Let us suppose if I write y is equal to x square, y is equal to a x square, or y is equal to a minus x square. So remember, if you plot y is equal to a square, then the graph would be like, so graph opens upward because this constant comes along with x square is positive, and if plot this curve, then the graph would be like, so graph opens downward because here the constant is negative before x square, isn't it? So this is, so let's have some examples by observing, by following some steps. How can you plot the graph? So here y is equal to ax, so this can be written as y is equal to minus 1 x square plus 4x plus minus 1. A standard equation is given by y is equal to ax square plus bx plus c. So here a is equal to minus 1, b is equal to 4, and c is equal to minus 1. So the step number 1 is, first we have to find the vertex. First we have to find the vertex. That is, x coordinate of vertex is given by minus b by 2a. So minus b, it means that minus 4 by 2. A is minus 1. So this will, it will be having value 2. It means that the vertex, now what is vertex? So this point is known as vertex. If you observe carefully, the left and right side of this vertex are symmetry, or you can say the mirror image of each other. The left and right side of this vertex are mirror image of each other. So first we have to find the step number 1 is obtain the x coordinate of the vertex. Then what happened? Substitute the value of x in this expression, then you will have the value of y, that is y coordinate of the vertex. So you will get minus 2 square plus 4 2 minus 1. So y is equal to minus 4 plus 8 minus 1. So y is equal to 8 minus 4, 4 minus 1, 3. So the coordinates of vertex are as follows. Coordinates of vertex becomes, that is 2 comma 3. It means that the vertex of the parabola is at point 1 2 1 2 3. So this must be the vertex of the parabola. Now let us have look at when this parabola cuts the, I mean, x-axis, then what will be its value? Or you can say when x is equal to 0, what is the value of y? So we can find it. To put x is equal to 0, we get y is equal to, this will be minus, where is the equation? Minus 0 plus, so y is equal to minus 1, है ना? Y is equal to minus 1. It means that the parabola cuts the y axis at minus 1. So the graph or parabola would be like, it passes through here, this is the vertex, and from here it will take turn like this one, isn't it? So this is the vertex, and it is passing through the minus 1, because when we put x is equal to 0, y is equal to minus 1. So in this equation we put x is equal to 0, we get y is equal to minus 1, and this is the vertex. And about this vertex, the parabola is symmetry, that is mirror image of each other. So in this way you can plot the graph. This is second example, you can say. So here also you can find the vertex. So the x coordinate of vertex is given by minus b by 2a. So this is minus of minus 4, because minus b by 2. So this will be 2, and corresponding to x is equal to 2, y is equal to minus 4. That is, coordinates of the vertex are 2 and minus 4. And when x is equal to 0, y is also equal to 0. The graph must passes through the origin. So this is the plot. Graph passes through the origin. So the x coordinate and y coordinate of the vertex are 2 and minus 4. This is 2 and 1 minus 1 minus 2 minus 3 minus 4. So this is the coordinate 2 minus 4 vertex. So the graph would be like, and the parabola must pass through the origin, because when x is equal to 0, y is equal to 0. So the graph would be like this one, parabola, isn't it? So you must know, or you must learn in detail only the straight line equation, where you must be able to convert the given equation into a straight line, and to convert the given straight line into the equation. And as far as parabola and hyperbola are concerned, you just need to have the idea whether this equation corresponds to parabola or hyperbola. So you can select the options, correct option from the given multiple MCQs, that this equation corresponds to which graph. Now the third is hyperbola. Whenever there is inverse relation, that is 1 by x to the power n, then this will be represented by hyperbola, and the graph would be like this one. Are you getting? When x approaches to infinity, y approaches to 0. When y approaches to infinity, x approaches to 0. So this is y and this is x. Suppose there is an ideal gas equation, that is PV is equal to nRT. Application in physics. And for isothermal process, that is temperature is constant, then this whole right hand side becomes constant. P is given by some constant by V, implies that P is having relation as inverse. It means that when pressure increases, volume decrease, or you can say when volume increases, pressure must decrease. So it's the plot between pressure and volume will be like this one, isn't it? So these are the examples. There are many more examples which we learn in the upcoming further lectures. That's all for this lecture. Thank you.